Hello students, welcome back to the channel. In this video, we are going to study about cardiac cycle. Now see, you know very well, heart has got two upper chamber that is known as atria and two lower chamber that is known as ventricle. So let me just draw and explain you, try to understand. These are the chambers and this is a tricuspid wall, bicuspid wall, and this is ventricle. And from the ventricle is arising, this is pulmonary artery, and you are finding semilunar valve is present here. And this is your dorsal aorta. And at the starting, you are finding here also semilunar valve. So basically try to understand where the valves are present, because in this we'll be focusing with respect to valve also. Now see here, try to understand this is the SA node which is present. So once the action potential is generated in the SA node, which coincide with the P wave of ECG, means atria systole will start. And atria systole will pass, or you can say because of the atria systole, contribution of 25 ml blood will be done to the ventricle, which was already having 105 ml. Means the blood which is present in the ventricle was already 105 ml, and because of the atria systole 25 ml is added, so total blood each ventricle is containing about 130 ml. Clear? And this is the end of the ventricle relaxation. We say this is end diastolic volume. So at the end of the ventricle diastole, how much blood is present in each ventricle is 130 ml. Clear? Now from the SA node, the message will be transmitted to the AV node. And from AV node, it is given to the AV bundle. From AV bundle, it is given to the right and left bundle. And finally, it is given to the Purkinje fiber, which will start the ventricle systole. Clear? For this conduction of the heart, please see another video. It will be helpful for you. Now see, for ventricle systole, what will happen? Systole means contraction. So when the ventricles are contracting, you know very well, when volume decreases, pressure increases. So what will happen? Ventricular pressure will increase. When the pressure increase, the first AV valve will close to prevent the backflow of the blood. So what will happen? They will pushes the blood against the AV valve, forcing them to shut. So AV valves are closed. Now, this happened immediately after the atrial systole, and it takes time only for 0.05 second. So we can say for about 0.05 second, semilunar has not opened and AV valve has closed. It means both valves are closed, AV valve as well as semilunar valve. All the valves of the heart are closed. We say right now it is isovolumetric contraction is going on. It means what? It means though the cardiac muscle fiber are contracting, but they are not shortening. Why? Because all the valves are closed right now. Now, after this, what will happen? After this, the pressure will increase more. So when the pressure increase more, okay, because continue contraction is going on, so pressure increases. Pressure increases. Why? Because volume is decreasing, the pressure is increasing. It will make the semilunar valve open, and the blood is ejected out from the ventricle into the respective arteries. Now, each ventricle will eject nearly 70 ml of blood. 70 ml of blood will be ejected out. So initially, before ventricle systole start, it was 130 ml, means this was end diastolic volume. Clear? And at the end of systole, how much blood is left? Because 70 is released, so how much is left? 60 ml is left after the end of the systole. So we'll say end systolic volume. So end diastolic volume is 130 ml and systolic volume is 60 ml. It means how much blood is ejected out? On only 70 ml, which is also known as stroke volume. Clear? Once again, please remember, and diastolic means how much blood is present in the ventricle at their end of the diastole, means their systole will start. Their systole will start. And how much blood is present after the systole is over. After the systole is over, how much blood is ejected out, how much blood is left in the ventricle, that is end systolic volume, and how much blood is ejected out, that is stroke volume. Clear? Now, next. Now, relaxation period. During the relaxation period, after the blood ejection, the ventricle will start relaxing. So, when the ventricles start relaxing, means ventricle diastole start, the pressure will decrease. When the pressure decreases, the chances of the blood which was ejected into the artery can fall back. So, the blood in the aorta and pulmonary trunks begin to flow back. Clear? So, backflow will, what it will do? Immediately close the semilunar valve. Semilunar valve are closed immediately because of the backflow of the blood. To prevent backflow, you can say semilunar valves are closed. Now, at this condition in the heart, what we are finding, AV valve has not opened till now and semilunar has closed. So, aortic valve close, okay, and semilunar valves are closed. AV valves are also closed. All four valves are closed and still no change in the blood component. Blood volume is not changing in the ventricle. We say volume is relaxing, but blood component is not, quantity is not changing. We say that is isovolumetric relaxation. Isovolumetric relaxation is a condition in which there is no change in the blood volume, even though heart is relaxing, because all four valves are closed. Is it clear? Because all four valves are closed. This is important. But when the further contraction is going on, further relaxation is going on, pressure is decreasing more, then what will happen? Then AV valves are forced to open and the ventricles start filling. Now let's try to understand this diagram. See here, this is the atrial systole, which is for 0.1 second. Ventricle systole is for 0.3 second and relaxation time is for 0.4 second. So one cardiac cycle is for 0.8 second. Now try to understand this diagram. See here, at the atrial systole, you can see here, atrial systole, the contraction of atria is done. And once the atria contraction is done, you can see here at this AV valves are closed. Okay, bicuspid or tricuspid valve will close. Now, try to understand, this is the pressure in the artery and this is the pressure we are talking about, the left ventricle. Left ventricle pressure. We are discussing with the one which is from where the dorsal aorta will arise. Now see this diagram, analyze it. This much time is there. How much time is it? It is 0.05 second. Right now in the theory I explain you, it is 0.05 second where all the four valves are closed. Tricuspid is closed and semilunar valve has not opened till now. We say this is isovolumetric contraction. When this valve is closed and this valve is also closed, they have not opened till now. After this, when the pressure is increased in the ventricle more than the artery pressure, then AV valve will be opened and blood will be ejected. We say this is ventricle contraction. Clear? Ventricle contraction is going on. Now, after contraction, the blood is ejected. Now, the pressure will start decreasing. So ventricle pressure start decreasing as compared to the aortic pressure, and immediately what will happen? See here, the semilunar valve will close. Aortic valve means semilunar valve will close. And AV valve has not opened till now. AV valve has not opened, and this is the one where you are finding all four valves are closed. We say heart is relaxing, but still blood movement is not going on. We say isovolumetric relaxation. After this, when the pressure decreases further, then it is decreased more than the atria pressure, then cuspid valve will open. And once the cuspid valve open, then the ventricle filling will start. means 70% of the blood will go passively, and again atrial systole for the remaining 30%. So I hope so this diagram, which is very, very important for your Olympiad exams, this might be helpful for you. Now see next. See, the atrial systole is for how much time? You can see it is for 0.1 second, atrial systole. When atria is systoling, ventricle is relaxing. Then now 0.3 second, ventricle diastole. When ventricle is relaxing, atria is going for diastole. So when ventricle goes for systole, atria goes for diastole. 0.3 second. This is the time when both are in the diastole condition. We say joint diastole. Joint diastole. Is it clear? You can see in the diagram. Please analyze it carefully. You can find here AV valves are open and blood is coming passively 70%. Again, contraction will start and 30% blood will be allowed to enter. Is it clear? And then ventricle systole, AV, the semilunar valve will open and the blood is ejected out. Now, in this diagram, try to understand when the valves are closed. Please learn carefully when the valves are closed, that time sound will be there. So when the ventricle systole was starting, what we studied when the ventricle systole was starting, first AV valve has to close so that blood should not go back. So you are hearing first sound, that is Lub sound. And Lub sound is because of the closure of tricuspid and bicuspid, and this is the first heart sound. Clear? Then second heart sound is heard when the ventricles start relaxing. When the ventricles start relaxing, then semilunar valve closed. So when the ventricles start relaxing, semilunar valve closed, and you will hear the second sound that is known as dub. So if we go with the diagram, please try to understand. See this. 0.1 second atria systole, 0.3 second ventricle systole, and 0.4 second joint diastole. So here, once the AV valve closed, you will get a sound lub. And here, once the semilunar valve closed, you will get the sound dub. So if suppose they ask you the question, how much time is between lub and dub? Answer is 0.3 second. But if they ask you how much time between dub and lub, I think so you can get an idea. It is 0.5 second. So in this video, I tried my level best to explain you cardiac cycle with the diagram and along with the theory. So this video might be helpful for you. Please see it again to make a revision. It will be helpful. Thanks for watching.